Hey, hello YouTube. Today, let's look at the leetcode 918, the maximum sum circular subarray. So given a circular integer array, and we need to return the maximum possible sum of a non-empty subarray, and this circular array means the end of the array connects to the beginning of the array. So this is actually means um, not only this kind of subarray is our consideration, and we can also consider this kind of a subarray. So that's so-called a circular subarray because we can actually start from here and then circulate here, then continue until we end here. So this is also a valid candidate as a subarray for us to calculate the maximum sum. So let's look at how to solve this problem with a canonical algorithm. So here I draw again this two situation, this maximum subarray problem and this circular subarray problem. As we discussed before, the maximum subarray problem, if our candidate is only this kind of subarray, canonical algorithm is the algorithm to use. That gave us the maximum subarray value. So now in this maximum circular subarray, we have more candidates to consider, right? So this kind of a subarray, like before, is only belongs to group one. We have a group two, which is this circulated manner. That's a group two. So we need to find the maximum subarray from both, right? Maximum here and maximum here. Then we need to actually compare them with each other, and then return the maximum from these two candidates. So this is actually the difference. So for the maximum of group one, we can still use the same method. We can just do the canonical algorithm, and it will return us the maximum subarray. For this group two, it's a little bit tricky. We need to find the minimum subarray using canonical, meaning that we're looking for this part, but this time it's not the maximum we're looking for, but it's the minimum we are looking for. Uh, the minimum in this group one subarray candidates. So once we have the minimum subarray in group one, then we can use the total sum of the array, which is a constant. If the array is given and it's not changing, then this is a constant, right? So it's not changing. So if we have the constant value, the total value, minus the minimum subarray in this group one, that will give us the maximum subarray in this group two, because the group two is nothing more than the rest of the array after the total array minus this part, right? So with this method, we could actually have the maximum subarray and then use this to compare with the group one's output and return the bigger result. So how to get this minimum subarray? So the method we're using here is to change all the value to its negative. Let's say here we have a value here, uh, 1, 2, 3, 4, 5. In order for us to get the minimum value, we simply put the minus sign for each of that, and then feed this array to the canonical algorithm, because canonical algorithm will give us the maximum. The maximum with this minus sign is the minimum without this minus sign, right? So this is actually the trick we use here. So with that, we will be able to get the minimum subarray, and that will then be used. We will subtract that one from the total in order to get the value we want. So this is the core idea. Okay, now we know how the algorithm works. Let's look at how we implement it in code. So we start by checking the corner case, and after that, we actually have this five variable and this loop here. So this part is a standard canonical algorithm. The goal of this implementation is to find basically the maximum subarray in group one, I should remember, and then the minimum subarray in group 1. Both are in group 1. Sorry, this is group 1. Both are in group 1 because we are using the Canadian algorithm. This is just a standard Canadian algorithm. And the way how we achieve this minimum subarray is to have all the value with a negative sign here for this the second sum here. So as you can see, here is a negative sign, and here is another negative sign. All the value for this part will be having a negative sign here. So the maximum sum 2, this is actually associated with the minimum sum, but it's actually equal to the minus of the minimum sum because it has the negative sign here. So we go through these for the using the standard Canadian algorithm. After that, we will have this maximum subarray and minimum subarray from both group 1, and this is what we want. And then come to this line here, we compare. This is from the group 1 maximum subarray, and then there's a total sum. This is what we accumulated as we iterate through, and this is actually the constant we were looking for, and that one will minus the minimum sub, right? So minus minimum sub, because as I mentioned, the value of this maximum sub is actually equal to the minus minimum sub, so we simply add this value. So this actually gave us the result of this one, and we actually compare which one is bigger, then return the bigger one. One thing to mention is we have this checking here. We want to make sure that all the value, the total sum and the maximum sum too, they are not equal. I mean, when they are plus together, they are not equal. If they are equal, that basically means all the elements in this array belongs to this minimum sub array. So that basically means we have no group 2 elements at all because uh, because the group 2 supposed to have this kind of um, this kind of format. But if we have all the elements like this belong to this minimum subarray, then we don't have any group 2. So that's why we only need to return group 1 here.